For decades, the message has been pretty simple, right? Avoid the sun. We've been taught to view it mostly as this giant, dangerous source of skin damage. But beneath the surface of that narrative lies a profound evolutionary truth. We are diving deep into human biology in this explainer today. And what we're going to see is that sunlight doesn't just warm us up. It fundamentally wires our autonomic nervous system. It modulates our systemic immunity, and it quite literally optimizes the deep architecture of our sleep. By breaking down the human body from a first principles perspective, we're going to reveal exactly how solar radiation orchestrates these incredibly complex biological cascades at the molecular, cellular, and neurological levels. Think about this for a second. Epidemiologists have long tracked a fascinating mystery known as the latitude effect. Basically, as human populations live further and further away from the equator, rates of cardiovascular disease, autoimmune conditions like multiple sclerosis, and mental health challenges like major depression, they all dramatically increase. It really begs the question, are these diseases spiking because of our modern, sun-avoidant, chronically indoor lifestyles? To understand this evolutionary mismatch, we have to look past the surface of our skin and deep into the mechanics of our biology. Which brings us to a massive paradigm shift. For terrestrial organisms, and yes, that includes us, solar radiation is an absolute evolutionary cornerstone. We really have to move away from this reductionist view that sunlight is just a vehicle for synthesizing vitamin D, or just a skin cancer risk. It is so much more than that. It's a vast systemic regulator of our entire physiological and psychological health. Okay, let's look at the first big piece of this puzzle. Section 1, the vascular revelation, nitric oxide and autonomic tone. We love a quick fix, don't we? But there is a stark contrast between the modern medical approach of just swallowing a vitamin D supplement and the multi-pathway reality of actual sunlight exposure. A capsule simply cannot replicate the full spectrum of solar benefits. I mean, actual sunlight triggers the release of beta endorphins for mood elevation, it drives serotonin synthesis via your eyes completely independent of your skin, and maybe most crucially, it provides the circadian entrainment you need to build up sleep pressure. You literally cannot get these systemic biological drivers from a pill. Let's track exactly how this works on a molecular level, because it is fascinating. When UVA light hits your epidermis, it interacts with vast stores of nitrogen oxides resting right there in your skin. The light essentially unlocks this nitric oxide, or NO, moving it directly into your systemic circulation. Once it hits the bloodstream, NO causes arterial vasodilation, meaning your blood vessels physically relax and widen. The direct, immediate result of this? A drop in blood pressure. And the crazy part is that this happens entirely independently of vitamin D, and even independently of the body's own internal nitric oxide synthase enzymes. The light does the heavy lifting. So how much light is actually required to trigger this effect? The answer is just 20 joules per centimeter. If you're wondering what that means in the real world, it's about 30 minutes of midday UVA exposure. Clinical studies using this exact dose demonstrate a significant systemic hemodynamic shift, lowering blood pressure and improving arterial compliance, without even raising core body temperature. The photons themselves, not the heat from the sun, are doing the metabolic work. Moving from the blood vessels to the brain, let's get into Section 2, the neural revelation, circadian rhythms and neural wiring. Deep inside your eye is a rare, specialized subpopulation of cells making up less than 5% of your retinal ganglion cells. They're called iPRGCs, and they contain this highly unique photopigment called melanopsin. Now, these cells don't help you see shapes or colors. In fact, they are completely decoupled from image-forming vision. Instead, they are intensely sensitive to 480 nanometer blue light. They act as direct, high-speed conduits, firing down the retinohypothalamic tract straight to the suprachiasmatic nucleus, which is the central master clock of your brain. Watch how elegantly this system plays out across your entire day. In the morning, that blue light hits your iPRGCs, entraining your master clock and driving serotonin synthesis to wake you up. But by the afternoon, something incredible happens. These cells rapidly adapt to intense daylight to prevent excessive light energy from disrupting your internal clock with biological noise. And finally, in the evening darkness, the absence of light signals your pineal gland to release melatonin, setting the stage for deep sleep architecture and glymphatic clearance in the brain. The light phase is every bit as critical to your sleep as the dark phase. And you know, this isn't just about sleep, it's about your mood and cognitive clarity. Sunlight directly regulates serotonin synthesis through a very specific gene called tryptophan hydroxylase 2. It essentially modulates the HPA axis, your body's primary stress response system. When we lack this solar input, our serotonin turnover dips, which directly correlates with what we now call major depressive disorder with seasonal pattern. We are literally wired to thrive under the sun's photons. All right, let's zoom in even closer. Section 3. the immune revelation, systemic community, and inflammation. Here's a huge moment of clarity in photobiology that we absolutely must understand. The sun is not just outputting one type of active light. It's a highly complex dual pathway system. As we've seen, UVA radiation primarily mobilizes nitric oxide, leading to cardiovascular benefits like blood pressure reduction. UVB radiation, on the completely other hand, is responsible for synthesizing vitamin D3, releasing mood-elevating beta endorphins, and producing peptides that drive systemic immunologic tolerance. Let's unpack that exact cellular cascade triggered by UVB, because it's wild. Once it initiates vitamin D3 synthesis in your skin's keratinocytes, an incredible anti-inflammatory wave begins. It suppresses pro-inflammatory cytokines like IL-1, IL-6, and IL-17. It actually shifts your immune system away from highly inflammatory Th17 cells and over to regulatory T cells, or Tregs, whose main job is to prevent autoimmunity. It even pushes macrophages into an M2 state, which is specifically focused on tissue repair. It's just this elegant systemic calming of overall inflammation. But of course, biology is all about trade-offs. Let's look at Section 4, Finding the Therapeutic Window, Balancing Biology and Dermatology. We have to impartially consider the established medical consensus from dermatology here. As Dr. Simon R. Desai, the president of the American Academy of Dermatology, rightly points out, any unprotected UV exposure inherently damages cellular DNA. The AAD maintains a strict stance for a reason. Cumulative cellular damage leads directly to melanoma and premature aging. Their message is very clear. The risk of skin cancer is an undeniable reality that we simply cannot ignore in the pursuit of biological benefits. So we have this tension. How do we reconcile these two entirely valid perspectives? On one side, we have dermatological reductionism, which views UV strictly as a dangerous carcinogen that has to be blocked at all costs to prevent skin cancer. On the other side, we have evolutionary holism, which recognizes the sun as a multi-pathway systemic regulator, absolutely essential for cardiovascular, neurological, and metabolic health. Now, as an explainer of the science, we aren't here to take sides, but we do want to highlight that optimizing human health means navigating the complex reality between these two scientific truths. And a big part of that navigation is understanding that systemic benefits operate within a very strict therapeutic window. What happens when you overshoot it? Well, if you exceed 2 hours of intense sun exposure, you trigger a self-defeating cascade. To cool you down and dissipate all that heat, your body rapidly shunts blood away from your brain and toward your peripheral skin vessels. This intense thermoregulatory demand causes transient perfusion deficits, which is just a fancy way of saying a temporary drop in blood flow to the microvasculature of your brain. Over time, that excessive exposure has actually been linked to localized brain tissue shrinkage and white matter damage. More is absolutely not always better. Which leaves us with a pretty profound final thought. We now know that sunlight isn't just a hazard to be avoided, nor is it a magic cure-all to be endlessly consumed. It's a precise, powerful biological input that entrains our circadian clocks, lowers our blood pressure, and calms our immune systems, but only provided we respect its boundaries. In an era completely defined by artificial light and indoor living, the challenge really isn't just about whether or not to wear sunscreen. It's about asking yourself, how will you carefully and safely reintegrate this vital evolutionary piece back into your own life? Thank you so much for exploring the deep biology of the sun with me today.